Alright, hey, welcome back. Today we're looking at functions and graphs in context. So for functions, what we're looking at is that every input has only one output. So there's a few ways we're going to look at it. We're going to look at it mapping, we're going to look at a set, and we're going to look at a graph and determine if we have a function or not a function. So I kind of separated it into two columns. So the left-hand column will be all the functions and the right-hand column will be all the non-functions. So again, for a relation to be a function, every input has only one output. So let's say we're looking at this first relation here. We have Joe, Mel, and Ray on the right. We have three people and we ask them what their favorite ice cream is. So let's say Joe likes mint, Mel likes chocolate, and Ray also likes mint. All right, this is a relation because each person only has one favorite ice cream. And that fits that every input, which is the people, have only one output, which is the ice cream. Okay, even though Joe and Ray like the same thing, it's still a function because each of them only likes one thing. All right, so let's look at what a non-function might be. So on the next relation, we have Terry, Dave, and Ethan. And then we have what kind of pets they have at home. So we have dogs, cats, and fish. So let's say Terry has a dog. Let's say Dave has a cat, but also a fish. And then Ethan has a dog. All right, this is a non-function because notice Dave has two pets. He has a cat and a fish, so he doesn't only have one output. He has two. He has cat and a fish. So this is a non-function. All right, so in set notation, what we're being given are points. So each of these points has an x and a y. So notice that 0 is an input, x is the input, and the output is 1. In the second one, the input is 1, the output is 2. And then the third one, the input is 2, and the output is 2. They have the same output for these two, but again, just like we said in the first one here, we can have someone have the same output as another person. That's still good as long as we don't have two of the same inputs going to a different, to more than one output. All right, so let's see what a non-function looks like in a set. So notice here we have 0 as our input and 1 as our output. Then we have 0 again with our 2 as an output, and then we have a 1 with a 1 as our output. So the part that's messing this up is these 2 points here, because notice we have an input of 0 and an output of 1 and 2. So just like we said in the top, in the mapping, because we have an input going to more than one output, 1 and 2, then we do not have a function. It's a non-function. Okay, the vertical line test is wordy, but once you understand it, it's really simple. So it says if we can draw a vertical line through the graph at any point that crosses more than once, it's not a function. So a function, it could look super curvy. Well, I should probably draw that a little nicer. Super curvy. But this passes the vertical line test because there's no point on this graph where I can draw a vertical line that passes through it more than once. However, if I want to draw a non-function, I just make sure that it overlaps at least once. So like a circle would be a super easy one, because at multiple points on this graph, we can draw a vertical line that passes through it more than once. Okay, so pretty straightforward. Now, the last example is the part of graphing in context. So it says you start walking to school from home. Halfway there, you stop at the park. You realize you're going to be late and run to school. All right, so if we're starting from home, make sure you read the graph correctly so that we know where we're putting our graph and how it should relate to your situation. So it says you start from home. So we're starting from home. That means our distance from home is 0 because we're not away from home, we're at home. All right, so it says we start walking. All right, so we're walking pretty slow. Halfway there, you stop at the park. So when we stop, we're not getting any further from home. We're staying the same. So this one should be a horizontal line here while you're at the park. And then it says, oh, you're late, so you need to go run to school. So we're not going to be walking at the same rate. It's going to be steeper. We're getting further from home quicker. So this is where we start running, and at the end is where we should have reached school. Okay, so you're going to be comparing graphs and choosing the best graph depending on what the situation is. And that shouldn't be too hard. Just remember where you're starting at. So in this case, we started at home. So our distance from home is 0. And then make sure that if we're getting further away, that we're increasing the distance from home on this interval here. Make sure if you stop, we're not getting any further from home. So it's constant. Your slope should be 0. And then if we're going faster, then your slope is steeper than if you were walking or going slower. All right, that's it. Good job today. Good luck on your homework.